Have you ever wondered why two welds done with the same machine and same electrode look completely different? One weld penetrates deep and looks strong, while the other sits on the surface and cracks later. The secret reason is polarity. Most beginners ignore polarity. Some professionals misunderstand it, but polarity decides how much heat goes into your metal, how deep your weld penetrates, how fast the electrode melts, and whether your weld is strong or weak. Today, we'll break polarity down step by step, with real welding logic, not confusing theory. By the end of this video, you'll never randomly connect cables again. In welding, polarity means the direction of electrical current flow. Electricity always flows from negative to positive, joule. Depending on how you connect your welding cables, either the electrode becomes positive or the workpiece becomes positive. This simple cable connection completely changes heat distribution, arc stability, weld penetration, high voltage. Important rule to remember: only se dahini or ishara, about 70% of heat is generated on the positive side. So whichever side is positive will receive more heat. This single rule explains everything about polarity. Before polarity, we must understand current types. Direct current, DC, flows in one direction only. Polarity remains fixed. Common in SMAW, TIG, MIG welding. Alternating current, AC, direction changes 50 to 60 times. Polarity keeps switching, used when balanced heat is required. DC gives control, AC gives balance. Let's start with DCEN, also called straight polarity. Connection. Electrode is negative, workpiece is positive. What happens? Electrons flow from the electrode to the workpiece. Since the workpiece is positive, it gets maximum heat. Results: deep penetration, strong fusion, faster melting of base metal, higher deposition rate. Where DCEN is used: thick steel plates. Root pass welding, TIG welding on steel. Applications needing strength. Engineering logic: you are pushing heat into the metal, not wasting it on melting the electrode. Now comes DCEP, also called reverse polarity. Connection. Electrode positive, workpiece negative. What changes? Now the electrode is positive, so it receives most of the heat. Results: shallow penetration, smoother weld bead, slower base metal melting, excellent cleaning action. Why cleaning happens? Positive electrode attracts electrons and breaks oxide layers on the metal surface. Where DCEP is used: thin sheets. Electrodes requiring soft arc. MIG welding. Stainless steel applications. Pushpin key idea. DCEP is about control and surface quality, not depth. AC polarity keeps switching between DCEN and DCEP, so heat distribution keeps changing. Benefits: moderate penetration, moderate cleaning, stable arc, reduced arc blow. Best application: TIG welding, aluminum. Why? Because aluminum needs penetration, DCEN effect, oxide cleaning, DCEP effect. AC gives both. Now let's understand how polarity directly affects weld quality. When you use DC electrode negative or DCEN, most of the heat goes into the workpiece. Because of this, the weld penetrates deep into the metal. You get a narrow, deep weld bead, but the cleaning action is low. This is why DCEN is ideal when strength and fusion are critical. On the other hand, with DC electrode positive or DCEP, the situation changes completely. Here, most of the heat is concentrated on the electrode, not the workpiece. As a result, penetration becomes shallow, but the weld bead becomes wider and smoother. The big advantage of DCEP is its high cleaning action, which helps remove oxide layers from the metal surface. So in simple terms, DCEN gives you depth and strength. DCEP gives you surface quality and control. Now let's talk about what happens if you choose the wrong polarity. Using incorrect polarity can lead to lack of fusion, where the weld does not properly bond with the base metal. It can also cause cracks, especially under load or vibration. Over time, this results in weak joints that fail much earlier than expected. But when you select the correct polarity, everything improves. You get a strong weld with proper fusion, a clean and professional appearance, and most importantly, a long service life for the welded joint. This is why polarity is not just a setting, it's a critical decision that defines weld quality. Now let's talk about some very common polarity mistakes that many welders make, especially beginners, but even experienced welders sometimes fall into these traps. One of the biggest mistakes is copying machine settings without understanding them. Just because a setting worked for someone else doesn't mean it will work for your material, your joint, or your electrode. Another major mistake is ignoring the electrode manufacturer's recommended polarity. Every electrode is designed to run best on a specific polarity. If you ignore that and connect cables randomly, the electrode simply won't perform as intended. A third common error is using the same polarity for all materials. Steel, stainless steel, and aluminum all behave differently under heat. Using one polarity for everything almost guarantees poor weld quality somewhere. That's why, before striking an arc, you should always check three things. First, check the electrode type. What polarity does the manufacturer recommend? Second, consider the material thickness. Thick materials usually need penetration, thin materials need control. And third, think about the welding process you are using. SMAW, TIG, MIG, or AC welding all respond differently to polarity. If you take just a few seconds to check these points, you'll avoid defects, save time, and produce consistently strong, clean welds. Polarity is not just a machine setting. It's pure welding physics. When you understand polarity, you're not guessing anymore. You are controlling where the heat goes, how strong the joint becomes, and how good the weld finally looks. In short, if you control polarity, you control heat, strength, and quality. If this video helped you understand welding better, please like, share, and subscribe to the channel. And if you have any welding questions, drop them in the comments. I reply to every serious welder. Happy welding!